What is software architecture? Software architecture comprises software elements, the relationships among them, and the properties of both. What does that mean? Think of any architecture and you will see some elements, some relationships among those elements, and the properties of both the elements and the relationships. The properties of elements may include concerns like scalability, security, availability, modifiability, what it holds, what it doesn't hold, what it can do, what it can't do, and so on. All of these are properties of elements. Then we have properties of those relationships. Is this unidirectional, bidirectional? Is this authorized, unauthorized, synchronous, asynchronous, allowed, not allowed, and so on? Now let's see some real architecture, the famous three-tiered architecture. It has some elements. Then these elements have relationships and then properties of both. Properties of elements and properties of those relationships. That's how software architectural diagrams look like. There are some boxes which represent elements. There are some lines which represent relationships. Let's see some more architectures. Hexagonal architecture, same, boxes and lines which represent elements and relationships. Web queue worker architecture, same, elements and relationships. Microservices architecture, elements, relationships. A class diagram, elements, relationships. Another class diagram in minimized state, elements. Wait a minute. This is a class diagram. A class diagram isn't architecture, right? Classes are written by developers. Creating them and connecting them through relationships like inheritance and composition is a job done by developers using simple coding. So how can this be architecture? But hold on. Class diagrams are very similar to architectural diagrams. The same boxes, the same lines. We have just seen that architecture consists of elements and relationships, which is also evident in the diagrams of various well-known architectures. Clearly, a class diagram also consists of elements and relationships. So why wouldn't it be considered architecture? It should be called architecture. The answer to the question is yes, a class diagram looks very similar to architectural diagrams. Yes, it has elements and relationships. But to call something architecture takes a little more than that. And those additional things are somewhat subjective in nature. For something to be considered architecture, it has to be a bit larger and more significant. The job of creating classes and connecting them through relationships isn't significant enough. Therefore, despite having elements and relationships, we don't call it architecture. Instead, we use a different word. We call it design. This means that creating classes and defining relationships among them is similar to creating architecture. But just because it's on a small scale, we call it design instead of architecture. But still, in its nature, it's an architectural task. Wow, that's thought-provoking. Let's put it this way. Designing objects may not be architecture, but it is certainly architectural in nature. If this is true, then there are some very important corollaries to this. Number one, this gives you architectural powers in coding. When you use object-oriented programming, when you analyze and break requirements into components and make classes out of them, when you design objects, when you apply design principles and patterns, you bring architectural powers in your coding. And architecture is indeed a very powerful thing. This is a car. You can see it as it is, as a single object. Or you can break it down into its components: wheels, engine, body, seats, and more. If you see it in components, you can create different types of new vehicles simply by changing the properties of each part and connecting them in different ways. Just by altering the number and sizes of the wheels alone, you can design countless types of vehicles. By changing the properties of wheels, you keep innovating. This is possible only because you are thinking in components. Thinking in components is an architectural skill, and indeed a very important one. Let's see another example. This is a skeleton. You can view it as a single entity, or you can break it down into its components: head, hands, legs, chest, back, neck, and more. The connections between these components have the properties of flexibility and mobility, which allows for a variety of postures. When the properties of those elements change and they are connected in different ways, the number of possible structures that emerge is unlimited. This leads to a never-ending stream of innovation. By using object-oriented programming, you bring architectural powers in coding. Number 2. This is your opportunity to become an architect. What do architects do? The primary responsibility of an architect revolves around quality attributes or architectural characteristics. They do jobs like designing architecture, documenting them, managing cloud infrastructure, doing deployments, technical and technological decision making. The role of an architect is a moving one. Sometimes they come close to the code, and at other times they move away from it. For example, in a microservices architecture with tens or hundreds of microservices, much of their time will be dedicated to architecting those services at a high level. On the other hand, if the application is a small monolith, the architect may also contribute in coding as well. What do they do when they come close to the code? They often review pull requests, PRs. While reviewing PRs, their focus is not on functionality, but on quality. They think less about what and more about how. Is it performant? Is it secure? Hope you haven't broken backward compatibility. They discuss maintainability, readability, reusability. They offer suggestions like, move this into a separate class, use an interface here. You are violating a design principle here. Use a design pattern here. They do the base work to set a foundation in which they use the same object-oriented principles and patterns. The foundation of some of the architectures that we saw earlier, like three-layered architecture, is laid in the same way by designing classes and using object-oriented principles and patterns. In addition, they place those classes carefully in separate projects or packages. On the other hand, what are the responsibilities of a developer? The minimum responsibility of a developer is to implement functionality. On top of that, they are expected to ensure quality as well. Developers take care of what, but they also think about how. They are highly encouraged to write maintainable, readable, and reusable code, which in turn means that they are highly encouraged to use object-oriented programming and use design principles and patterns. Did you notice? These are the shared responsibilities between developers and architects. This is the area where the roles of architect and developer overlap and merge. If you see it this way, it becomes your opportunity to become an architect. Just by focusing on how and using object-oriented programming, you engage in what architects do. You may not have access to AWS or Azure or Google Clouds. You might not be involved in discussions about the breakdown of microservices or the scalability or availability requirements. However, designing classes is well within your domain. When you design classes or objects, you practice architecture. You can practice it every day, and no one can stop you from doing it. In fact, it's encouraged. It's true that sometimes the pressure to complete what is so high that we neglect how. And often this pressure is external, but many times it stems from a developer's own laziness. Additionally, many developers often overlook this aspect because they think it's less important. However, if you are fortunate enough to recognize this and refine your approach and perspective, then this brings you a great opportunity. As we have already established that the job of designing objects is architectural in nature. If you aspire to become an architect, then object-oriented programming is the most logical start. It's the most logical because the architect's ladder begins here, right in your domain. It starts exactly where you are standing. All you need to do is start climbing, and sharpening your object-oriented skills is your first step. Finally, by focusing on object-oriented fundamentals, pillars, principles, and patterns, by reading, learning, practicing, and using them, you significantly enhance your chances of becoming an architect. It's possible that you may not receive the official title as there are some other factors involved. However, you will develop an architectural approach and mindset which will benefit you in various ways. It's also possible that you don't even aspire to become an architect, as you have different plans. However, by executing your current job more effectively and exceeding responsibilities, you do your part and signal that this is your time to grow, no matter what direction you choose. It's also possible that you want to remain a developer. You love coding. In that case, you will become a very different kind of developer, the kind that is rare. In that case, you will code on a whole new level. You will code like an architect. You will code like an architect.